This lecture will be on hurricanes. You can find some information in Chapter 12, Section 9 of your textbook. A hurricane is a severe storm that forms over the ocean. It is a rotating cloud storm that rotates counterclockwise. It has a well-defined eye, which is the calmest part of the storm in the very center. And the storms are associated with strong winds, heavy rains, and very large waves. Hurricanes are a low-pressure system, so winds are coming towards the center of the eye. And notice it's going to go in a clockwise, so it's like a clockwise spiral. In the very center, that's your eye, which there is no clouds or very little clouds. The strongest winds are going to be what's called the eye wall, just at the outer edge of the eye itself. Hurricanes need a couple of things to form. First, they need warm oceans, so they're typically forming in the tropical regions. And they need a low pressure system with some global winds and Coriolis force to get it spinning. So you're not going to find hurricanes directly on the equator because there is no Coriolis force and there's no global wind pattern. But you're going to find them just north or south of the equator. Then as they move across the Atlantic Ocean, due to the Coriolis force, they're going to eventually curve upwards, and then the westerlies will push them back out to sea. What months will be considered hurricane season? Think about what we need. We need warm water, we need global winds, a low pressure system, and the Coriolis force. The seasons aren't going to change the global wind patterns too much. Seasons won't change the Coriolis force. So let's think about water. We need warm water. So what seasons are we going to find the warmest water? Not summer. Because water has a high specific heat, it takes a very long time for the water to heat up and a very long time for the water to cool down. So the ocean's at its warmest around the end of summertime and into the fall. So hurricane season would be like August, September, October, because those are going to be the months in which the ocean is the warmest. These colors represent the ocean temperatures. So the warmest temperatures are going to be like the orange and yellow. So we would expect to see a lot of warm temperatures near the equator, and we do. But again, notice we don't have any hurricanes forming directly on the equator. Here's a side note. Hurricanes are formed in the Atlantic Ocean. Typhoons are formed in the Pacific Ocean. They're the same thing, just a different name. Also notice that they form just above and below the equator. And because of the Coriolis force, they're going to get deflected to the right in the northern hemisphere. And they're going to get deflected to the left in the southern hemisphere. So for the United States, they're going to generally start forming off the coast of Africa. And they're going to travel along the equator, and then they're going to curve up once they get close to the United States. These dates show you the hurricane season. Typically, it's going to be between August and September for the eastern part of the United States. In the Pacific Ocean, notice the times are a little bit different. That's because we have this major global wind pattern system that blows all this warm water over towards the western part of the Pacific Ocean, so they have a larger section of warmer water. Also notice in the southern hemisphere, the dates have changed a little bit. That's because our seasons are switched, remember. If it's summer in the northern hemisphere, it's going to be winter in the southern hemisphere at the same time, and vice versa. If it's our winter up here, it's going to be their summer down here. So the fuel for hurricanes come from the warm tropical waters. Generally, the warmer the water, the stronger the hurricane. And water must be about 79 or 80 degrees Fahrenheit in order to form a hurricane. When the water's this warm, we have a lot of evaporation, adding a lot of moisture into the atmosphere, forming those clouds. Hurricanes can create a lot of damage. A lot of people think of the high winds. However, the most amount of damage comes from what's called a storm surge. Because we have this very large storm pushing all the water up onto the land, we're going to have a rise in sea level. The greatest damage from the storm surge is to the right of the eye of the hurricane because that is where the wind is pushing the strongest towards the shore. Storm surges are the cause of most deaths in a hurricane. And we do have high wind speeds, and it can rip houses apart, buildings apart, but a lot of our damage and danger comes from our storm surges. So here you can see the winds and the storm surge. So this is normally all land, but the wind is pushing the ocean up onto the land. This boat landed on the land because the storm surge pushed it up. And here are some wind damage images. Just as tornadoes are rated on a enhanced Fujita scale, hurricanes can also be ranked. This scale is called the Saffir-Simpson scale. The tornado scale, the Fujita scale, went from an EF0 to an EF5. The Saffir-Simpson scale starts at 1 and goes from 1 to 5. So a category 1, the hurricane strength wind speed must be 74 miles per hour. If it's below 74 miles per hour, it's considered a tropical storm. So our hurricanes start out as what's called a tropical depression, then it can upgrade into a tropical storm, and then once the wind speed reaches 74 miles per hour, it's considered a category 1 hurricane. It can go up to 95 miles per hour. The storm surge is typically 4 to 5 feet. We'll get minimal damage. We might get some tree damage, some siding and roof damage, but nothing too major. Category 2, we're looking at 96 to 110 miles per hour. The storm surge is 6 to 8 feet, and we'll get some moderate damage occurring, such as shallow-rooted trees might get uprooted or snapped off. Category 3, 101 to 130 miles per hour. Our storm surge is 9 to 12 feet. Many trees are snapped off and uprooted. Roofs are now being removed. Katrina at one point was considered a category 3. We'll talk a little bit more about Katrina in a few minutes. I want to go back to storm surges. So a storm surge of 4 to 5 feet doesn't sound like it's very much, but you have to remember these storm surges are happening at the coast where the land is pretty flat. So 4 to 5 feet is going to go inland pretty far. And obviously 9 to 12 feet is going to go in a lot farther. Okay, category 4. The wind speed is going to be 131 to 155 miles per hour. The storm surge is now 13 to 18 feet. Most trees can be snapped or uprooted. Power line poles and roofs can be torn down and off the buildings. Charlie in 2004 was a category 4. And a category 5, we're talking wind speeds greater than 155 miles per hour. Our storm surge is greater than 18 feet, and we're going to have catastrophic damage. Almost all trees are going to be snapped or uprooted, and the power poles are definitely going to be down. Homes are going to have total roof and wall destruction. Hurricane Andrew in 1992 was an example. Now, if we compare an EF5 tornado to a Category 5 hurricane, the wind speeds are going to be pretty different. A Category EF5 tornado can have wind speeds greater than 200 miles per hour, where a Category 5 hurricane, it's going to be a little bit less than that. Here's a little more information on Katrina. Based on the wind speed, Katrina was only a Category 3 by the time it reached lands, and it had wind speeds of about 127 miles per hour. The problem with Katrina was the flooding. The flooding of Katrina was very catastrophic. This left about 250,000 people displaced of their homes, and this is a higher number than the Dust Bowl years in the 1930s. As of early August 2016, the death toll exceeded 1,800 people, and the total damage and the cost of the damage was $125 billion. This is just a before and after photo. You can see the buildings completely wiped. This is mainly because of the storm surge. Flooding was a major problem for Katrina. Here's why. Now I'm going to exaggerate this, but this is a cross section. So here's Katrina, here's a little building, and this is the Mississippi River flowing in here. On the sides, we have what are called levees. New Orleans is a major city for importing and exporting goods because the Mississippi River goes all the way up through the interior of the United States. So a lot of ships travel up and down transporting goods. So based on the economy, we don't want the Mississippi River to move. And the Mississippi River actually wants to move towards what's called the Atchafalaya River right next to it, because the Atchafalaya River is in lower elevation. But humans don't want the river to move, so we built these levees up to keep the Mississippi River where it is. So the Mississippi River will constantly, every day and night, every second of every minute of every day and night, it's going to be bringing and carrying sand, silt, and clay downriver. And as it becomes flatter and flatter, the sand, silt, gravel, clay, etc., is going to build up at the bottom of the river. And as it's building up at the bottom, it's going to cause the river to get a little bit higher, the height of the water to rise up. We don't want the river to flow out, so we build our levees a little bit higher. And the water is going to rise up to match it. So this is how the river actually is at a higher elevation than the city itself. Well, Katrina came through, and when Katrina came through and the storm surge and the winds, it broke our levees, our little man-made levees. When that broke, all of the river then flowed downhill and into New Orleans, flooding New Orleans. So this graph shows a river, and normally the river is at a height of about, we'll say, 6 feet. When the levees broke, that 6-foot river jumped up to 26 feet. So the river rose 20 feet. That's almost unimaginable. This is another little stream. Normally it's at about 2 to maybe 4 feet. So on its low spot, only 2 feet, you could walk across that without getting your shorts wet. But when the levees broke in the river, that 2-foot stream shot up to about 15 feet. This picture is showing you the rainfall that Katrina dumped. So in the southern part of Florida, you can see the hurricane cross just the southern part. Southern part, there were points where they were getting 12 to 17 inches of rain. Then it came up through New Orleans, and again, New Orleans got like 12 to 17 inches of rain. This is on top of the levees breaking, so major, major flooding. But you can definitely see the path that the hurricane took. Notice how it arcs. That's again because of the Coriolis force. When we name hurricanes, we alternate male and female, and we start at the beginning of the alphabet with A and then proceed through the alphabet. And we don't name tropical depressions or tropical storms. We only give it a name once it's reached a Category 1 status. If a hurricane does extensive damage, we retire that name, and that name is no longer used again. So Katrina, for example, is not ever going to be used again. The list then is recycled every 6 years. And 2005 was the first year that we used up all the letters in the alphabet, A through Z, and then we had to move on to the Greek alphabet. This could have been an indication that our climate was starting to change, because as our climate is changing, we're noticing we're getting more hurricanes, plus we're getting more intense or stronger hurricanes. A few years ago was the first year that I've ever seen 4 hurricanes in the Atlantic Ocean all at the same time. Remember, hurricanes in the northern hemisphere move counterclockwise towards that center of low pressure system. In the southern hemisphere, this is Brazil, so here in this picture we're in the southern hemisphere. Remember, it's going to go the opposite, so because of the Coriolis force, so it's going to go clockwise towards the center of the hurricane. We can see a well-defined eye in the center, and again, right next to that eye is the eye wall, which is going to have the strongest wind speeds. The eye itself is going to be relatively calm with little to no clouds.